Good afternoon, ladies and gentlemen. With a big pleasure, I want to present you some research work of our scientific team. The name of my presentation is Structure of Nanolameral Solid Solution at High Pressure and High Temperature. Max phases is a class of ternary carbides and nitrides with the main formula M plus 1 A X N, whereas M is early transition metal, A is A group elements, and X it's either carbon or nitrogen. So from the main formula we can receive the next stoichiometry, such as 211 for n equal 1, 312 for n equal 2, and 413 for n equal 3. Up to now, more than 60 max phases have been identified. Mainly it's 211 phases. Only six members of 312 phases and 5 members of 413 phases have been identified. It's known that we can receive different solid solutions both on M sites, A sites, or X sites. In this work is devoted to structure investigation of titanium-2 carbon nitrides. This solid solution are very important members of max phases solid solution on X site. And the investigation of these materials is interesting not only to understand the correlation between elements in this compound, but we hope that this investigation offers how to tune these materials for their application. So max phases has a hexagonal crystal structure that consists M6X octahedra that interleaved with M element layers. That's why these materials are nanolaminated layered materials. Existence of strong bonds between M and X elements and weak bonds between M and A layers endow such solids unique combination of metal and ceramic properties. For example, these materials have a good resistance for oxidation, for corrosion. They are high shifted. At that time, they have a good electrical and thermal conductivity, mechanical. So in such properties of these materials increase a big interest in among the scientists in physics, chemistry, and material science. So for our work, we synthesized bulk materials of solid solution using hot isostatic pressing technique. As initial compounds for synthesis was used titanium, aluminium, aluminium nitride, and titanium carbide powders. They were mixed during 4 hours and pressed into pellets and encapsulation into Purex containing containers under high vacuum. Then the synthesis process was performed during 4 hours under a temperature of 1400 degrees and pressure 80 megapascal. So on this slide you can see the samples before heaping, after heaping, and after removing the glass. But the porosity of these samples, the biggest porosity was discovered in pure titanium to aluminum nitride. The porosity of these samples was equal 45%, and the porosity decreased with increasing of carbon content down to a value of 32 degrees. Using X-ray powder diffraction analysis, we estimate that the main phases of our sample is solid solution, carbon nitride solid solution, then not big amount of titanium aluminide was found near 4%, and some amount of 312 phases, and its amount increased with decreasing of nitrogen content. Also, before the initial powder, we exceed the 10% of alumina, because we will lose this element during the synthesis process by evaporation. So using EXD analysis, we estimate that in our solid solution, the in average ratio between titanium and aluminum is equal to 2. That confirms this loss of alumina. Also, we estimate the structure parameter and A parameter linearly increase with increasing of carbon content, but for C parameter we discover some phenomena, because the value of C parameter for our carbon nitrides solid solution are lower than the pure nitrides and carbides. So, but the cell volume linearly depend from content of carbon due to the Weger's law. So in literature we found that we can have some deficient in our carbon nitrides due to the information that titanium carbide can form a wide range of single phase solid solution with X equal from 0.5 till 0.95. So we decided to investigate, can we receive substoichiometry solid solution, carbon nitride solid solution, and can we have some deficient in pure 211 carbides and nitrides. For this, from this point of view, and also according to the literature data, we found that some of 312 phase can 21 phase can have deficient not only in X position but in A position too. But and from theoretical calculation, it was estimated that near 30% of vacancies can exist in pure titanium to nitrides. So for this from this point of view, we synthesized some of solid solution with deficiency in X position. The value of Y was equal from 0.8 to 1, and from X-ray powder diffraction analysis, we estimate that for carbonitrides, the increasing of deficiency, the increasing involved to the containings of our samples, and additional amount of additional phases increase with increasing of our deficiency. And here we can see our result for all solid solution, and you can see that increasing of additional phase increase the amount of the increasing of deficiency increase the amount of additional phases. So we determine from X-ray powder diffraction, we estimate all true values of X and Y, and it was established that we can receive substoichiometry solid solution, carbonitride solid solution, and some deficiency in nitrides, but not for pure carbides. But the main task of our research work was application of these materials, but with the big porosity, more than 45%, it's impossible to estimate different physical properties. So we try to densify our materials using high pressure technique, and our solid solution was densified under pressure 2 gigapascal and temperature that correspond to the synthesis temperature at hot isostatic pressure, but the process was the time of process was 1 hour. So from X-ray powder diffraction, we estimate that our high pressure didn't destroy max phases, and mainly more than 92% of max phases were found in our samples. Some additional phases, such as titanium aluminide and titanium carbonitrides was found, but no more than 5%. And we estimate A and C parameter, and you can see that the dependence linearly depends from the carbon content. And for these densified samples, we measured the mechanical properties such as Young modulus and microhardness, and discovered that this value not so clearly depend from content of carbon on nitrogen, but for the sample with this composition, the Young modulus was the bigger one. And from DTA measurement, we estimate that the oxygen resistance increase with increasing of nitrogen content. So it's all. Thank you for your attention.
Perfect. Time for questions. So thank you again.